This is how we're going to find the distance from a point to a line. So let's recall a few things. So we know that the distance from a point is going to be the length of or the shortest distance from a point to a line is the length of the perpendicular segment from that point to the line. So let's call this point A. So we're going to be finding the distance from point A to that given line there. So we're going to break it down into steps. The first step is to write an equation that's going to be perpendicular to the line that we're going to find a distance from. So let's recall that perpendicular lines, their slopes are opposite reciprocals. So if I have my line here, which is y equals negative x plus 3, I want to find the slope that's the opposite reciprocal to that slope of that line. Now the slope is always the number before x, is the coefficient. In this case, there was no number there, which means that there was an imaginary one. So the slope for this line is negative 1. So what I'm going to do is take the opposite reciprocal of that slope, which would just be positive 1. So remember, reciprocals means that we're going to swap the numerator with denominator. Now in this case, the numerator was negative 1, and the denominator is also 1, so the reciprocal is just 1. So here's my general form for writing equations of slope-intercept form, which is y equals mx plus b. My m will be, like I mentioned, positive 1, since that's the opposite reciprocal of negative 1. And if you wanted to, you don't have to include the 1 next to the x. We know that if there's no coefficient there, we assume that there's a 1 there. And it needs to go through that point. So let's go ahead and plug that point into my equation that I have right now. So my y coordinate is 0, and my x coordinate is 1. Everything else in the equation, I'm just going to bring down. So the 1 plus the b. Multiply the 1 and the 1, that gives me 1. Then I'm going to isolate my b by subtracting 1 from both sides, so then I get my b, which is the y-intercept, is negative 1. So the equation that's perpendicular to this line is y equals the slope, which is positive 1. And this time I'm not going to include it, so I'm just going to put x. And the y-intercept, which is negative 1. Okay, we have two lines now. They're perpendicular to each other. And we're going to go ahead and graph them so you can see. We're going to confirm that those lines are in fact perpendicular. So let's graph the first equation. So my y-intercept is 3, that's my starting point, and my slope is negative 1. So I'm going to start on the y-axis, go down 1, and to the right 1, since my slope is negative 1. I get a few points in there so that I have a straight line. So here's the line that the problem originally gives me. I need to now graph the other line, which I created, that's perpendicular to that green line. My starting point on this one is negative 1 and has a slope of up 1 to the right 1. So as you can see here, we have two lines that are perpendicular to each other. And the reason why I want lines to be perpendicular, because I need to find that segment that's perpendicular to the line so that I can find the distance between the point that I given to the green line. So on this graph, we're going to go ahead and label our point. And what I highlighted is that perpendicular segment that I need to find the length for. If I know that length for that perpendicular segment, then I'm going to know the distance from point A to the green line. Now, because we have a graph, it's easy to see the 2 points that I need to find the distance from. But if we weren't given, then we need to find another way to find that intersection. And that way is by creating a system of linear equations and solving for it. Finding the solution, which is where the lines intersect. So let's go ahead and write down our two equations that we have right now, which is the equations for the green line and the blue line. We need to find the point where they intersect. Like I said, we have the graph, so it's easy to see, but we don't always have the graph. So in Algebra 1, we learned how to find solutions to a system. One of those methods was substitution. So what I'm going to do is I'm going to set those equations equal to each other because they're both equal y. So that means that they're equal to each other. And then we're just going to solve for each of the variables. So I'm going to solve for x first, since that's the only variable I have in the equation. So we're going to continue solving for x here, bringing our variables to the same side. Now isolating our variable, and we get that the x-coordinate is 2. To find the y-coordinate, all we need to do is plug it into one of those equations. And it doesn't matter which one you plug it into. Whichever one you plug it into, you'll get the same result for y. I'm going to plug it into the first one, and we get the y coordinate is 1. So if we didn't have the graph, this is where the lines would intersect. But because we have the graph, we can confirm that they do intersect at that point. So what I'm looking for is the distance between this point here, which is where they intersect, that's where they form the right angle, and the point that I'm looking to find the distance from. So we're going to use our distance formula and find the distance between those 2 points. So here's my distance formula. Here's my equation, my formula for the distance formula. All right, let's go ahead and label what goes inside the first parentheses. Remember, you can swap the y sub 2 with the y sub 1. It doesn't really matter the order because you're assigning which of the points is your x sub 1 and your x sub 2. I'm just going to go from left to right on the points. So if I look at my x coordinate for the first point, that would be 1 minus the x coordinate for the second point, which is 2. And repeat the process for the y coordinate. Let's go ahead and simplify the first parentheses. We're going to get -1. Inside the second parentheses, we happen to get -1. Those are not always the same. Anytime you square a negative number, it's positive. So we simplify here. We're going to get the square root of 2. But because we're finding the distance, let's go ahead and give an approximation in decimal form, since 2 is not a perfect square. So if I take the square root of 2, that would give me approximately, and I'm going to be rounding to the nearest hundreds, so that would be approximately 1.41. So the distance between those 2 points, it's 1.41. Remember, distance is always positive, so if for some reason you're getting the square root of a negative number, you're going to get an error because we are working with real numbers. So just go back and check your work. All right, so let's make sense of what we just found. So there's this point, right? Point A. That point is 1.41 away from the green line, which is the equation that we were given initially. So As you can see here, the highlighted segment, it's what I just found that it was that has a length of 1.41. That's all you need to do when you are finding the distance from a point to a given line.